and it's time to start the demonstration of the Field MicroProfiling System. I hope you will be able to see this. I will try to shift back and forth between camera and software and so on, and I hope it should work. Just as the other presentation, please make sure your microphone is off so you don't make any noise during the presentation. Then ask questions in the chat if you want. Lina is still on, I believe, and otherwise just ask questions after the demonstration. So I will get started. First, now you should see the setup I have here. So this is the Field MicroProfiling System, which consists of the field multimeter, which is a very handy amplifier with built-in battery and so on. I have the field motor over here with the micro manipulator on, and I have some sensors, and I have a sediment core where I'm bubbling with atmospheric air at the moment. I'll just briefly show you the field multimeter. So the field multimeter is a battery-powered thing. You can run it on a power supply if you want. It can also run up to 20 hours on battery. It has 8 channels for sensors, so 5 for the amperometer, 2 potentiometric, and 1 temperature sensor. It can be operated by the software fully, so the only thing you need is the on-off button, but you can also operate it totally on its own, so a standalone instrument. It has a keypad here, which you can use to operate it. The first page, I don't know if you can see that, but it shows the signals from all 8 sensors, and you can see which are connected. I have 2 oxygen sensors connected here. You can operate the motors and control them from here. You can see the signal of the sensors if you want. You can make sequences. That is, you can make a program that will, for example, make a microprofile, so you can determine the distance between the distances between points and the time and so on. Once you've saved that, you can run it by pressing the start button, and it will just execute this program, and you can do that again and again. Then you can see the deployments that are there, so the data sets that are on it. You can see the status of it, so is it charged and so on. Is something running, and there are some settings, firmware updates, and so you can do here. But that's the only thing I'm going to tell about the field multimeter. Now I'll just use it as an amplifier for this setup here. So, and what I have here is a sediment core I want to measure a profile in, and I have an oxygen sensor, which I will calibrate in a moment. I have water here in a calibration chamber being bubbled with air, which is now in equilibrium with air. And I have my calibration kit here, which is a 0 oxygen solution, and the calibration cap to put on the sensor. I'll get back to that in a moment. First, I would like to start the software. So I'll just take over the screen. As you've seen now a couple of times, the Unisense software consists of these different parts of the software. The one we'll use now is the profiling, so I'll double click that and get it started. When you start any of these parts of the software, the first thing it will do, it will look for connected Unisense instrumentation of any kind. And here it found a field multimeter with the serial number, and it has found that the field multimeter has 2 sensors connected. Oxygen sensors, both of them. I have 2 oxygen sensors with a tip diameter of 50 micrometer ready for this profiling. You can choose other sensors if you want. You see there are a lot of different ones you can choose from. Most of them will actually be recognized automatically, so you don't need to choose it. There are a couple where you need to choose it. You can choose what unit you want to work in. The default unit is micromoles per liter, and that is needed if you want to use the analysis part of the software. That will only work with micromoles per liter, not the other ones. But you can, if you want, work with percent saturation, milligrams per liter, nanomoles per liter, millimeter mercury, Pascal, or arbitrary units. But for this, I'll just use the micromoles per liter. You can give the sensor a name if you want, and you can add a comment as well. Down here, the software has found the motor connected. So what it actually finds is the motor controller, which there are two of in the field multimeter. I only have one motor connected, and that is connected to the connector for motor 1. So that is the one I will use, and it is designated to be the Z axis or C axis. And once you've set things the way you want here, the sensors are selected, they are correctly set for types and for units, you'll click Start Experiment, and that actually means you will create a file. It suggests just the numbering of the files, and I'm now at 89. I'll just accept that, and it will create the file. From now on, when the file is created, whatever you do of recordings, calibrations, and so on, it is automatically saved to a database. It is there's not any file save button in this software. It saves everything that needs to be saved. So the first window you see when you open the software, that's the calibration window. We'll need to calibrate the sensor. I'll get back to this in a moment. I'll first show down here, it shows the live data. So it shows the two sensors I have connected, and it shows the signal in millivolts. You can, if you want, grab this and make it bigger. So if you want to look more careful at the signal down here. Over here, you can just decide how long a period you want it to show data for. Now it's 5 minutes, that's standard, I'll use that. You can choose calibrated or uncalibrated data. Now it's not calibrated, so if I choose calibrated, then it doesn't show anything. You can click hold if you want to look into some details, and you can click the Y zoom, which is really smart, because if you click the Y zoom and click and hold, then you will just zoom in on the signal, and you can keep doing that as far as you want. Then double click anywhere and it will zoom out to include all data. If you don't click the Y zoom, then you can zoom in and look on a specific part of the data just as you want, and double click to get out again. I normally use the Y zoom because what I want to investigate is easiest with that one. So we have different settings up here to work with. First of all, there's the manuals. You can find all manuals. They are installed together with the software. So if you want a manual for a sensor, you will find them on your hard drive after you have installed it. You can see they are there as PDF files, and that's the same for all the other manuals. There is a tool, so there are some calculator tools. You can calculate concentrations for these 4 gases. I'll get back to that. I'll use the one for oxygen in a moment. And it also has the file menu where you can use an import from instruments. So if you have recorded a profile on the field multimeter, you can import the instrument afterwards from using this, and you can also import calibrations. Okay, so to these options here, the motor settings, that allows you to set settings for the motor. We have this one active now. It is a motor, could also be manual. Then if you have it manual, then the software will prompt you to move the sensor every time a sensor must be moved. If the motor is active, then the motor will do it. You can have an extra motor if you want. So if you had a second motor, you could activate that here. And a third motor, not for the field profiling system, but for the lab profiling system. We can have 3 motors, so 3-dimensional. Okay, so the profiling, that is how you measure the profiles and use that. We will get back to that in a moment. Once your profiles have been measured, they will appear here in the Visualize tab. The Activity tab is for doing the calculations on the profiles, and I will get into that after with the presentation after this demonstration. And then the comment, and the comment will show you whatever has happened during your experiment. Right now we've just started it, so not much. And you can also add comments, which I'll show also later. Then the comment will be saved with a timestamp, so you know exactly when the comment was made. So I'll now start calibrating the sensor. As I've mentioned earlier, we need 2 points for the calibration. One would be a 0 and one would be a known concentration. I'll start with the known concentration. So now I will put the sensor into the calibration chamber. And you see when I touch the sensor, it gives a bit of noise always, and now it's in the calibration chamber. The temperature there is about 22 degrees and now has to stabilize. Then I need to tell it what the concentration is in the calibration chamber, and for that I'll use the oxygen table. So 22 degrees, I'll enter that. I will be measuring in water with 22 per mil salinity, so I will enter this, so I get the correct conversion of partial pressure to concentration. Then you can also enter the pressure, the atmospheric pressure, which will also affect the concentration in equilibrated water. This is the standard atmospheric pressure in millibar. I will not change that now. And then you can enter the gas concentration in the calibration gas you're using. And in this case, it is atmospheric air, and that is 20.946% oxygen. So this is pre-filled, so I will just accept that. And that then the concentration in the water will be 240.19 micromoles per liter. Now I click apply, and then this value is transferred to here. In the meantime, this has stabilized. Oops, sorry, like that. So you can see it's now stabilized, so I'll accept this. So I'll just click add point, and now I have my calibration point for the known value. Then I need to make the zero calibration, and to do that I will just stop the screen sharing. So you should now be able to see the setup. I have this zero calibration solution which I will inject into the sensor. So I'll take the sensor from the calibration chamber and just mount it in a holder. Then I have a cap that can be mounted on the sensor like this. And I have a zero solution and a syringe. All this comes with the calibration kit. The calibration kit contains 10 of these zero solutions. So I'll now just fill the syringe. Okay. And inject the zero solution so that it gets up around the sensor tip like this. And I'll share my screen again so you can see the. So now you can see that the signal has dropped a lot and fast. I will zoom in here and see if we are down at a stable level. So it takes a little while to get down to the full response. It's, as I mentioned, we normally talk about 90% response. It's about 5 seconds for a sensor like this, or maybe 3. But now it has stabilized. So I will enter 0 in the known value here, and then click the add point. And I now have a 2-point calibration, and I'll save and use the calibration. Okay, and now the calibration appeared down here. Yeah, and you can see there are 2 calibration points, what the slope is and what the intercept is and what the R² value is. When you only have 2 points, the R² values is pretty close to 1 always. And the timing of it, so you can see later if you do other calibrations, then they will appear down there. I will remove now the calibration liquid and the cap as well. So, and the oxygen or the sensor signal comes up, and then I will just wash the sensor in some pure water, because this zero solution has a really high capacity for oxygen consumption, and I don't want to have that in there. So away with that. Okay, so now I would like to measure a profile in the sediment core. So I will need to mount the sensor in the micro manipulator. So the sensor sits in a protection tube. Always when you receive it, it's a sort of a snap-on protection tube, just as the calibration cap. Then you remove the protection tube carefully, and you put the sensor into the sensor holder here on the micro manipulator. Okay, like this. Okay, so now I'm more or less ready to go with the sensor mounted. Now I just need to find sort of where is the sediment surface relative to the sensor. So I'll just turn off the bubbling for a moment so I can better see where the sensor tip is. And this is a very old and dirty plexiglass tube, so not so easy. but I am now somewhere close to the sediment surface. Then I'll switch to the software, because then it's easy to find. Okay, and now just zoom out down here again. This one away. Okay, so you see now we have, I can click the calibrated, and now we have a calibrated micromolar concentration for the for oxygen here, and that's also shown over here in the live data here all the time, 240 micromolar roughly. Then I'll go to the profiling part. And before we get close to the sediment, I would like to set up now the profiling setup here. So we will need to tell the software where to start the profile, where to end the profile, the step size, and how long time it should wait after reaching a position until it should start the save the data and move on to the next depth. We should tell it for how long time it should measure. 1 second is normally fine, so we will measure, I think it's about 60 data points for this during that 1 second, and save the average of those and also the standard deviation of those. You can measure several replicates in each depth if you want, so you should just change this to something else than 1. You can have, if you do the replicates, you can have a delay between the replicates in seconds. You can add that here. And then you can also do a number of cycles. That means actually a number of profiles, one after the other. So if you put 3 here, that it will automatically profile 3 times. Finally, there's a sensor angle. If you, for some reason, need to go into the sediment at an angle, for example, 45 degrees, you will enter this here, and then the software will calculate the vertical distance between the sediment surface and the position of the sensor tip. So, and then the sensor has to be moved further than it should, because it's coming in at an angle, but that's all calculated by the software. In this case, I would like profiles to start at 0. I think I will let it go to 4 millimeters or 4,000 micrometers. The first profile, just not to waste too much time, I will go in at 250 micrometers at a time, so 1/4 of a millimeter. The safe distance is the position where the software will park the sensor after the profile has been finished. I will just put it to 0 because I'm operating it and I know where the sensor is. If you are leaving it, you want it come back after an hour tomorrow, it may be smart to park it up high away from any animals that could be in there. I think I would like to measure for 5 seconds, wait 5 seconds before I do the measurement for 1 second. So that now this is set up. Then we need to find where to start the profile. And now, because of this very murky sediment or plexiglass tube, I can't really see where the sensor is. So now I'll just go to the motor control here for the for the depth axis. So the actual depth is 0. Then I can set either a new depth and click the go to, or I can set a step. I would normally set a step of 1 millimeter here because I think I'm just a few millimeters away from the sediment surface. And then I'll click down. And then I will follow the concentration down in the live view to see, it didn't change this time. Let's try again. And when I get close to the sediment surface or the diffusion boundary layer, the concentration will decrease. And I know then I'm close to the sediment surface. May need to go a few millimeters more. Still no change. Aha. So now we are close, probably in the diffusion boundary layer. I'll just go 1 millimeter back then. And then we should maybe just a little further back. And then forward in smaller steps. 500 micrometers down, and then if it's still stable, this is where I'll start the profiling then. So I only need now to decide which sensors I want to use in the experiment, and since it's only channel 1 I have mounted and calibrated, I'll use that one. Close this window here, and then just click the play button here, and it will start recording. So I get a warning here because I forgot something. Beware that the motor is not at position 0, then I cancel because I don't want to continue. I just want to change this to be position 0, so set this as the home position. Now it's 0. Then I'll try again. Well, you can't see this, but the motor is now moving, the spindle is turning, and it is measuring. So this was the first data point. They will be plotted here as, whenever it measures. In the beginning, you'll have a very large scaling down here. So you see this goes from 241 to 44. So, but as soon as we get in to sediment, the scale will change and it will look much less noisy. And you'll see at the end it's actually not very noisy. So now it's just moving along, measuring for every 250 micrometers. And it seems we're getting close to the sediment now. We're now at 205 micromolar or so. And you can also follow the actual concentration down here if you want. And now it rescales. So now it starts from 0 to 300 micromolar. And then it's probably going to decrease the oxygen concentration. And then as you go along, you may discover, as I have done now, that maybe I'm not all the way down to 0 at 4 millimeters. So I'll now enter 6,000 micrometers instead. And you can change this as you go along. It doesn't matter. But this seems to be a really strange profile here. I don't know what I've hit. Yeah, now it's going very fast down. There could be some kind of an animal here. Okay, and now we're getting close to 0. Oops, I should do this, sorry. You can always zoom in also in this graph by clicking and holding and dragging, and then you can get in and see the details. You can double click and get out again. Now we're getting close to the 0 concentration. It's, yeah, just around 0, a little negative, a little positive. Just record one more data point. Okay, I'll stop now. Click the stop button. If you don't click the stop button, it will just continue down to this 6 millimeters and then it will return. Now I've stopped it, so it asks me if I want to return. Yes, I would like to get the sensor out. And then I will move the sensor a little bit horizontally and make another profile. See if we can get something that's less weird than this. Okay, there's 2 millimeters to one side, and then it's just click the start button again. And then it will, you'll see the profile growing from the top now here. This was the first point. And then it will continue doing this. So down here you can choose if you want to see calibrated or not calibrated values in the display here. So if I change this, then it's millivolt values, and now it's micromoles per liter values again. You could enter a comment if you've done something, added something to your experiment, or just wanted to know this is core number 1. Then you can enter this and click add. And then you can see the comment over here in the comment tab. So at this time, I entered this comment. And this will also be exported to Excel files and CSV files if you choose to export your data. So you have this as a sort of a logbook if you want to use that. As soon as a profile has been recorded, it will show up over here in the Visualize tab. You can see this was the first really strange profile that was measured. And soon the next profile will also show up over here. And once you have profiles, you can go into the activity and you can select them there and do calculations on them. But let's see now. Then you can decide if you want to see them all. I do not want to see the first one at the moment. So let's just see without the first one. So this is a nicer profile. And if you decide to mount 2 sensors in the sensor holder, this is actually a 2 sensor holder, I don't know if you noticed, then you can of course record the signal for all the sensors you have mounted, all 6 of them, all 8 of them that is room for on this field multimeter. Down here you can also investigate, see if you have set your timing correctly. So you can zoom in on this and you can see this stepwise decrease in oxygen concentration. It seems that I have not really given it long enough time that it's, well, it's almost stable. I think it is stable before we move on to the next. But this is a good thing to check depending on this, on the response time of the sensor. Now it's zoomed down at the end. I'll just make sure it doesn't stop before. So I will enter it 7,000 now. I think it's okay. So a very heterogeneous profile here. It's not normally you would see a more smooth profile, but it all depends on the sediment, of course. This is an old sediment core that's been in a bucket here for a long time. I think this is now 0, slightly below 0. Just stop it and pull the sensor out. Okay. So you see the profiles have now grown over here and are saved here as experiments. If you go into the visualize, you will see the profiles you've recorded, and you can choose if you want to see the calibrated and uncalibrated values. You can choose if you want to see standard deviation, the standard deviation that is recorded when the data points are recorded, and it's almost impossible to see because it's so low. And sometimes you can see it up in the turbulent layer right above the sediment surface that the variation is higher. Okay, and finally, you can also export profiles. So if you click the export, you can choose Excel or CSV files. I'll just export an Excel file, put it out on the desktop, and just go to, and then see if I can find number 2 out here. This one here, yeah. Okay, so here you see the profiles. So from experiment 1, so this is the first profile. This is the second profile. Oops, like this, you can see the data here. Each of these will show you the profile name, the depth, the data point is measured, and also if you are using the 2 other measures, you would see the position of those. It will show the timing when it was recorded. It will show the raw signal in millivolts and the calibrated signal in micromoles per liter, and the standard deviation, also micromoles per liter in the calibrated value. Then it will show the devices, that is the equipment you've been using with serial number and so on, and what units you've chosen and all that. That's all mentioned here. It will show the calibration data. So this is the calibration I did a while ago. So there was the concentration for the known concentration. This was the 0, and this were the signals for it, and the slope and so on. It will show the comments. So you see, we started the experiment here, calibrated channel 1 here. Applied the calibration, and I also entered a comment, which is mentioned here, core 1. So that was the comment I added, and then it shows just some information about versions of software and so on. So this is a very handy way of getting data into to other software, whatever you might want to use. I think the only thing I didn't mention yet is that the settings here is still available. But now this was the one that I filled out before creating the file. And once you've created the file, you cannot change these things. You can see what you chose, but you cannot change them. But they are available, the settings here. And with that, I think I want to finish, and I'll be happy to answer questions if you have some. Okay, please, yeah. Ketil, you have a question, please go ahead.
Yeah, so the standard deviation that you showed in the table, what is that the standard deviation of?
It is, in my case, I chose to measure for 1 second at each depth. Then it measures, I believe it's 64 measurements. I can look that up. I think it's 64 measurements during that 1 second. And then it makes the standard deviation of those and the average of those. It saves the average as value for the data point and the standard deviation, so you can see any variation in that. And what I mentioned is if you are in a turbulent layer where there's a variation in the oxygen concentration, you can now and then see that the standard deviation is larger than it is when it's in a stable environment in sediment where there's no turbulence.
You also had the option of measuring several data points at the same level.
Yes.
Wouldn't that be a measure of the same, sort of?
Yes, that would be also, I think that would be better actually for seeing the diffusion boundary layer and the turbulence right above it, because I think the data saved during this 1 second are probably saved. There are too many, so the standard deviation will not be so long. Be so big. If you save data points every second for 10 seconds, you'll have a better idea of the variation, I think. Yeah.
All right, thanks.
Yes. Anyone else?
Then we have a question in the chat there.
Yeah. So I did get that opened. Yeah. So do we have to do some calculations on the raw data signals shown in the table to get the actual concentrations? No, you don't actually. They are just saved there, so you have the millivolt signals, and yeah. So if you for some reason want to do a correction or something, you can do that. But the calibrated value is calculated using the calibration that is currently active, and yeah, then you have all you need. How can I see in the program how many points have already been measured? Or do I have to count the points in the profile to do this? Well, it doesn't show the exact number of points being measured, actually. It shows just the, yeah, you can count them, of course, but or you can calculate them because you know the intervals. You've measured them, whether you know the distance you've measured. So, but I'm not sure if I'm understanding the question correctly. Do you have to aerate the sediment core as you have in your setup in the demo? Well, it depends. You have to make sure you have some steering in the water phase so that the water phase is homogeneous and so that the concentration of, in this case, oxygen on the sediment surface is constant over time. That will give a steady state profile and allow you to do all the diffusion calculations on the profiles. In some cases, in this case, I just want air saturated water because it's a sediment core from a very shallow station out here, just on the beach out in Aarhus, and there's normally just air saturation in the water. So that's why I have air saturation here. If I was working in another estuary with low oxygen concentrations in the bottom water, I would create a system where I could have a gas mixture with a low oxygen concentration and bubble with that, so I could maintain a stable oxygen concentration, but an oxygen concentration that was the same as in situ. So that there are different ways of doing it, but the important thing is that you need to have aeration in the water column above the sediment. And if you're working in an anaerobic chamber, yes, then you should. Well, first of all, if it's anaerobic, there's no point in measuring oxygen. But if it's low oxygen, which I expect you will be doing in an anaerobic chamber or a chamber with low oxygen concentrations, you should put the whole thing into the chamber, and you should still make sure that you have mixing in your water column. You could put a small magnetic stirrer in that was held on a rod something, or you could bubble with a gas mixture that has the correct oxygen concentration, but you must have steering in there. Yeah. Thanks for your attention so far, and make sure to write us if you have any questions, or get in touch with us if there's something else you want to know. Thank you for now.